Hello, this is Engineer Gladys Grace Restauro Narit, and I will continue discussing to you about units, physical quantities, and vectors, or chapter 1. So let's tackle about vectors and vector addition. So there are two kinds of quantity. The one that is scalar and the other is vector. When we say scalar, it is just a number with the units. For example, 5 meters. So it's just a number. Another example is weight or a mass. Let's say 50 kilograms. So that's a scalar quantity. Or uh, for the length, uh, 10 meters. So that's also a scalar quantity. Another example is temperature, 30 degrees Celsius. That's also a scalar quantity. So it's just a number, a physical quantity. But when we say vector, it has both a magnitude and a direction. So it has a number but with a direction. For example, 5 kilometers east. So there is a direction east. Another example, 10 kilometers southwest. So that is also a vector because it has a number or a magnitude and then a direction. Another example, 3 kilometer north of west. So that is also another vector quantity. So the difference of scalar and vector, scalar is just a number, while vector, it has a magnitude and a direction. Displacement, it is also a vector quantity. It is a change in the position of an object. So let's look at the figure here. So displacement as a vector quantity. So it is represented by an arrow that points in the direction of the displacement. So it says here P1. This point here, this black, it says starting position. From P1, the point moves to P2 or its ending position, called P2. So the displacement, it's called big letter A with the arrow above. So it says here handwritten notation, big letter A with an arrow above its letter. So that's the notation for displacement. Okay, so when we say displacement, it's just the distance from the origin or from the starting position to the ending position, or in this figure from P1 to P2. Okay. In this figure B, a displacement is always a straight arrow directed from the starting position to the ending position. It does not depend on the path taken even if the path is curved. So in this example, the point moves in the direction of the arrows. If you look here, it goes here and then turns around up and turns above up to point P2. So this is the path taken, so curvy. But the displacement is just a straight line from P1 to point P2. That is just the displacement. So it doesn't matter how you got there, how the point got in there, but in the displacement, what the length just matters. So from the origin to the end position, so that's the displacement. Bisan pag unsa kalayo ang iyahang gidaganan, dili na siya magmatter as long as ang iyahang distance as long as displacement ang gipangita, because displacement is just a straight line. from the starting point to the final point. So this is displacement A. So if you look at the figure A, so in figure A, from point 1 to point 2, the movement of the point is just a straight line. But if you look here, the movement of the point is not a straight line, but they have the same displacement. Displacement A. Then total displacement for a round trip is 0, regardless of the path taken or distance traveled. For this in this example, in figure C, from point P1, okay, so the point moves here and then goes here. So it's also a curvy movement, but goes back to its original position. Since displacement is just the path taken from its origin to the final destination, so the displacement of this point is equal to 0 because there is no difference in its original position with its final position. So that is displacement. The meaning of vectors that have the same magnitude and the same or opposite direction. Okay, so vectors has magnitude and direction. Okay, let's look here in this point. Point P1 moves to point P2. So it has a displacement of A. And then point P3 to point P4. It has a displacement of A prime. But the movement of these points from P1 and then from P3 to P2 and then to P4 is just the same. So their displacement is just equal. Therefore, they have an equal vectors. It says here displacements A and A prime are equal because they have the same length and the same direction. Okay, let's look here at in this point. This point started moving from point 5, P5, to point 6. Okay, although they have the same magnitude with the A, but it has a different direction because it moves downward. Displacement B has the same magnitude. Okay, so it has the same magnitude because same lang ang i-move ng point, but opposite direction. So, displacement B is the negative of displacement A. So, it is negative because it moves in the opposite direction with the vector A or of the displacement A. Okay, vectors and vector addition. 3 ways to add 2 vectors. Okay, you can also add vectors. A, we can add 2 vectors by placing them head to tail. Okay, so if we look here in vector A, so its head is in the arrow and its tail is in the opposite side. Okay, displacement A, this vector, and then displacement B or vector B is here. So the vector sum or C, vector C, to the head extends from the tail of A to the head of B. Okay, so gikan diri sa tip sa tail ng A up to the head of B. So vector C equals vector A plus vector B. Okay, in another situation, look here in figure B. Adding them in reverse order gives the same result. Okay, so vector A is placed above vector B. So from the head of vector B to the tail of vector A. So vector B is connected to A through head to tail. Okay, so if we add it, if we make a line here, so that is vector C, we see that it just it is it has the same vector or resultant vector with the figure A, or by the way the figure A is added, the vectors in figure A is added. So that's another way of adding vector. Letter C, we can also add two vectors by placing them tail to tail and constructing a parallelogram. Okay, so you can uh, put the vector here. So this is tail to tail connection. The tail of vector A is connected to the tail of vector B, and then you draw a parallelogram. Okay, so this line here is just a parallel to vector B, and this broken line here is just a parallel to vector A. So if you draw a parallelogram and then make a line or a vector from the tip, from the tails of vector A and vector B up to this corner. So if you add it, that is just also the same with the resultant vector that is in here in figure B and in figure A. So vector C equals vector A plus vector B. So whatever process you'll do, you'll just get the same resultant vector. Okay, adding vectors that are parallel and anti-parallel. So letter A, only when vectors A and B are parallel does the magnitude of their vector sum C equal the sum of their magnitudes. Okay, C equals A plus B. Okay, it is only applicable that you will add directly the magnitude of the vectors if the vectors are in parallel. Okay, so vector C equals vector A plus vector B rather. Okay, so the magnitude of this vector C will just be equal to A plus B because they are parallel. However, in the situation here in figure B, when vector A and vector B are anti-parallel, meaning they have opposite direction, the magnitude of their vector sum, or uh, magnitude of the vector C equals the difference of their magnitudes. So that is the absolute value of the difference of A minus B. The absolute value of A minus B. So that is the magnitude of C, or the equation still applies. Vector C equals to vector A plus vector B. But the magnitude of vector C equals the absolute value of A minus B. So you can do that directly when the vectors are anti-parallel, or their direction are in opposite, or their vectors have an opposite direction. So this is only applicable in this situation when the vectors are parallel or anti-parallel. Several constructions for finding the vector sum A plus B plus C. Okay, how about three vectors? What if there are three vectors to be added? Okay, in figure A, to find the sum of these three vectors, you can also use tail-to-tail connection. So the tails of vector C, vector B, and vector A are connected. And then letter B, add, so another figure, another way, add vector A and vector B to get vector D, and then add vector C to vector D to get the final sum or resultant vector. So the way here is you add first vector A and vector B. After adding, you get the result of vector D. Once you get the vector D, you add it to vector C. So vector D plus vector C equals to vector R, or the resultant vector. So as you see here, it is connected. First, the A plus B is connected by through head to tail. And then when the vector D is solved, it is the head of the vector D is connected to the tail of vector C. And then you draw a line here and solve the resultant vector. Letter C. Or you can also do this. You can also add vector B and vector C first, and then you can get the resultant vector here, that is vector E, and then vector E plus vector A. So vector A plus vector E, you add it, then you'll get the resultant vector. But whichever way you'll use, you will always get the same resultant vector, that is the R. So you may use head to tail or tail to tail way. Another is, or add vector A, vector B, and vector C to get the resultant vector directly. So this is the figure. Vector A plus vector B plus vector C, so equal to the resultant vector, this blue arrow. Or you can also do this. Add vector A, vector B, and vector C in any other order and still get the resultant R. So as you see here, i-drawing lang nimo ang arrow using its magnitude and direction, and then connect it head to tail. So head of A connected to tail to B, and then head of B connected to the tail of C. After that, you draw a line from the tail of A to the head of C, and that is the resultant vector. That is also the same with this figure. Nauna lang niya og drawing ang vector B, and then discern niya drawing ang vector A, and then vector C, and then you draw a line from the tail of vector B to the head of vector C, and that is still the same resultant vector that is solved in vector D, figure D, figure A, figure B, and figure C. So whichever process you use, it will always get the same resultant vector. Okay, to construct the vector difference, vector A minus vector B, you can either place the tail of negative vector B at the head of vector A, or place the two vectors A and B head to head. Okay, so if you subtract a vector, you draw it head to head. Okay, so subtracting vector B from vector A equals, so is equivalent to adding negative B to vector A, negative vector B to vector A. So when you subtract, balihon lang nimo ang direction sa isa. For example, so ang ipangita dire is difference ng vector A sa vector B. So you draw the vector A. So mo na ang vector A. And then ang given is mo na siya ang vector B nga given. But sa imong pag-solve ani, balihon nimo ang vector b. A negative vector b nimo para ang mabuhaton nimo is i-add. So, vector A plus negative vector B. So, kinegative nimo ang vector B para ma-change ang direction. And then, you can use the methods in adding a vector. Okay, so, you can use it here this way from head to tail. Okay, from A, vector A, the head of vector A is connected to the tail of vector B. And then, from the tail of vector A to the head of vector B, you can draw this arrow, which is the resultant vector. You can also do this by connecting head to head. Head of vector A is connected to the head of vector B, and then you draw the arrow or the resultant vector from the tail of vector A to the tail of vector B, and then you'll get the resultant vector. So we'll discuss the vector addition, vector difference, and then multiplying a vector by a scalar. Okay, multiplying a vector by a positive scalar changes the magnitude or length of the vector but not its direction. Okay, so if you have a vector, let's say vector A here, and then you multiply it by a positive scalar, meaning a number. So in this example, vector A is multiplied by 2. So 2 is just a scalar number, a scalar quantity, because 2 doesn't have a direction. Okay, so it becomes 2 times vector A. So vector A just become 2 times longer than the original vector A. So 2 times vector A is twice as long as vector A. So that would be the result if you multiply a vector to a positive scalar. Okay, letter B, multiplying a vector by a negative scalar changes its magnitude and versus its direction. Okay, so given here, vector A, ang vector A daw multiplied by a negative 3. Okay, since the scalar quantity that is multiplied to the vector is, okay, so the vector changes its position because of the negative scalar. Okay, so this is what happens when you multiply a vector by a negative scalar, and this is what happens when you multiply a vector by a positive scalar. Okay, always remember, when a positive scalar is multiplied to a vector, its direction doesn't change. But when a negative scalar is multiplied to a vector, the direction of the vector changes. Okay, example 1.5. A cross-country skier skis 1 kilometer north and then 2 kilometer east on a horizontal snowfield. How far and in what direction is she from the starting point? Okay, so the vector diagram drawn to scale for a ski trip. Okay, so the 1 kilometer that the cross-country skier skis, so it says here to the north. Okay, so let's look here at the direction, or that we will be using. So east to the right, west to the left, north upward, south downward. So this is the direction that we will be using. Always remember this. Okay, so let's go back to the example. 1 kilometer to the north. Okay, so 1 kilometer. And then the skier goes 2 kilometers east. Okay, so the question is how far and in what direction. So you draw a line from the starting point to the finish point of the skier, and that is the resultant displacement. Okay, so the solution is here. Okay, so as you see in the figure, it draws, so it shows you the resultant displacement. Okay, as you see, the figure or the vectors that we draw is just a triangle figure. Okay, so we can use the Pythagorean theory, the Pythagorean equation in solving the resultant displacement. So you can use the Pythagorean equation, that is c squared equals a squared plus b squared. Okay, so 1 kilometer squared. So the resultant displacement or the displacement is 1 kilometer squared plus 2 kilometers squared, or rather, square root of 1 kilometer squared plus 2 kilometers squared, or that is equal to 2.24 kilometer. Okay, so for the direction, you will use a little trigonometry. Okay, so for the position or the direction, tangent alpha equals tangent okay, so tangent angle equals to opposite side divided by adjacent side equals 2 kilometer divided by 1 kilometer, or that is just equal to 2. And then arctan equals, and then angle equals to arctan of 2, or equals to 63.4 degrees. Okay, so we can describe the direction as 63.4 degrees east of north, or 90 degrees minus 63.4 degrees equals 26.6 degrees north of east. Okay, so that is the displacement. So final answer is 2.24 kilometer, 26.6 degrees north of east. Okay, any question? Clarification, just PM me. Okay, quiz will be posted in Google Classroom. Thank you for listening.